right, we're going to take a look at the molecular view of water. So water at a molecular level, the molecules within it. So water is made of two elements, hydrogen and oxygen. We put the twos there, the H2 and the O2. We don't just put H and O because they are considered diatomic molecules. So they are still elements because they're made of only one type of atom, but elements can sometimes be more stable if they appear in twos or threes or fours, eights. There are common ones. They're called diatomic. They all appear in twos, and these are the 7 elements that do that. So hydrogen, chlorine, bromine, fluorine, iodine, nitrogen, and oxygen. If you put all those together and sort of make a word, you can use the word huckleberry pheno. Huckleberry pheno kind of can help you. It's like an acronym that can help you remember which elements they are. If you're more of a visual person, they are all bunched together on the periodic table. So nitrogen is right here. And then you have oxygen, fluorine, chlorine, bromine, and iodine. So that's 6. And see how, remember I said there were 7 total? It kind of makes the number 7 from nitrogen over to fluorine, then down to iodine. So that number 7 right there, that is actually only 6, but hydrogen over here is the last one. So hydrogen plus those 6 that make that shape of 7 are the 7. So if you're more visual, maybe remember it like that. If you're more auditory, remember it as huckleberry pheno. Either way, you guys will need to know those. They appear in twos and they're called diatomic. There's 92 naturally occurring elements. We do have some man-made ones. These down here are man-made. It just means we made them in a lab by merging 2 or more of these nuclei together. We smushed them together and made new molecules. Compounds are when 2 or more elements are joined together. So they have to be joined by a chemical bond. It can't be a mixture. And this is what that would look like, where you have a central atom and then you have separate, different atoms coming off. Water is an example of a compound. Water has an oxygen in the middle and then 2 hydrogen coming off. This looks like it could be water, right, with an oxygen in the middle and 2 hydrogen coming off. But it also could be something like nitrogen dioxide, right? Nitrogen would be in the middle and then you'd have 2 oxygen, or carbon dioxide. Carbon would be in the middle with 2 oxygen. So we don't really know which molecule this is, but that is sort of how a molecule might be represented, with these acting as bonds and then these like balls acting as the atoms. We have so many compounds because you can take all of those elements and combine them with other elements, and it can be a compound. It might have 2 elements. It might have a hydrogen and oxygen. It might have 3. Maybe it has carbon, hydrogen, and oxygen. It might have even more than that. So there are a lot of different ways to combine elements to make a compound. And then a molecule, so 3 vocab words, right? Element, compound, molecule. A molecule is the smallest unit of a substance. So a molecule can be a element. Notice I called these diatomic molecules. So it is a molecule because it's just the smallest unit of a substance. It is also an element. This here is a molecule, but it is also a compound. So a molecule is just the smallest unit of any substance. It can be an element or a compound. So how do we make water? We take hydrogen and oxygen and put it together. So these H and O are the element symbols, and then these 2 down here are subscripts. Superscripts is how we write charges, which we're not quite to ions yet, but that's how we write charges. And then subscripts is how we tell how many there are. So this 2 here means that there are 2 hydrogen. This 2 here means that there are 2 oxygen. So those 2's are subscripts and they tell how many atoms there are in that molecule. So here in H2, I have 2 H's. And here in O2, I have 2 oxygen. And then that's the reactants of my water reaction. My product is water, but notice in the water, I have 2 hydrogen and only 1 oxygen. So something else happened to that other oxygen, and we're going to see what that is. So here is the full, what we call balanced reaction. So you can't, I said that oxygen was missing. It can't just disappear. It has to go somewhere. So when I split these oxygen up, one will go to this H2 and then one will find another H2 detached to in order to create water. So here's sort of a visual representation. We use these big twos in front. We use them, we call them coefficients, and they tell how many molecules we have. So subscript tells me how many atoms in that molecule, and then the big coefficient tells me how many molecules. So this means I have two H2s. So that's what that looks like here. I have two H2s. Here I have one because there's no coefficient in front, which means I have one. I have one O2, and that's going to make two waters. So here you can see I have two water molecules. The oxygen in the middle, which came from here, and then the hydrogens, which came from this first one, and then the second one, that's the other oxygen with these hydrogens. That means this bond broke here and then split up and bonded with each of these. How you can check to make sure that you're what we call balanced is you can count. On this side, on my reactant side, how many hydrogen do I have? I have 1, 2, 3, 4. And on my product side, how many hydrogen? 1, 2, 3, 4. So 4 and 4. I'm balanced. Reactants. I have 2 oxygen over here. How many do I have in the products? I have 2. 1, 2. So again, those are balanced as well. So I have 4 hydrogens on the left, 4 hydrogens on the right, 2 oxygen on the left, 2 oxygen on the right. Equal numbers means that the reaction is balanced. So that is how water is made. Looking at it at a molecular level, we see the full balanced chemical equation for how water is made, taking the diatomic molecules, hydrogen and oxygen, adding them together to get water.